Hello students, you are welcome once again to Prep Class Tutors. My name is Mr. Chima and I am your Prep Class tutor on chemistry. So now, if you see or if you are listening carefully, you notice that I use the word you are welcome once again. Why? Because this is not the first time that we are solving past questions on chemistry. If you have been following our previous videos, we've solved past questions on chemistry, Jamb specifically, questions number 1 to 40 for Jamb past question for the year 2020. On our WIRE channel too, we have also destroyed questions 1 to 50 of past questions on WIRE for the year 2020. But today, Mr. Chima is going to be taking you on past questions on chemistry for Jamb for the year 2019. So, students, a quick one. Do not forget to subscribe to our YouTube channel, like our videos, try as much as possible to drop your comments on our comment section box so that PrepClass will know how our videos have been very helpful to you. When you subscribe to our channel and like our channel, you'll be getting more and more fantastic educational videos like this. Okay, so very quickly, we are going to be looking at questions 1 to 5 for today on what? Jamb. On Jamb for the year what? 2019. All right, so quickly, let's go. Question number 1, and it says, if sulfur 4 oxide and methane are released simultaneously, if sulfur 4 oxide and methane are released simultaneously at the opposite ends of a narrow tube, the rates of diffusion of, that is RSO2, that is rate of diffusion of sulfur 4 oxide, and RCH4, rate of diffusion of methane, will be in the ratio. So if you see now, they are asking you to compare these two gases, sulfur 4 oxide and what? Methane. Sulfur 4 oxide and methane. If you place both of them at the end of a tube, that is, this one is at the end of this tube, this other one is at the end of that tube, which one would diffuse faster? That's the meaning. Which one would diffuse faster? Now, remember that from Graham's law of diffusion, that the rate of diffusion of a gas is inversely proportional to the square root of its molecular mass. That law, first of all, states the rate of diffusion of a gas is inversely proportional to the square root of its vapor density. That's square root of the vapor density of the gas. But it can also be written as the rate of diffusion of a gas is inversely proportional to the what? Square root of its molecular mass. Why? Because molecular mass is equals to 2 times the vapor density of a gas. So now we are going to be stating this second one, that restating it by saying that Graham's law of diffusion, the rate of diffusion of a gas is inversely proportional to the square root of its molecular mass. So now, if you see here, okay, in the ratio, this, no, now they didn't give you, there is something that is supposed to give in here. They're supposed to give you atomic masses of each of, like sulfur oxide now contains sulfur and oxygen. They're supposed to give you atomic masses of sulfur, oxygen, and atomic masses of carbon and 12. They didn't give you, but at least in some, at this level, they expect you to know if you've been solving chemistry. So sulfur oxide SO2 equals what? 32, because sulfur, atomic mass of sulfur is 32, plus atomic mass of oxygen is what? 16. So 2 atoms of oxygen, that's 2 times 16. So 32 plus 2 times 16 is 32. 32 plus 32 is what? 64. Then CH4, methane, carbon atomic mass is 12 plus 4 atoms of hydrogen, that's 4 into brackets. Atomic mass of hydrogen is 1. So that's 4 times 1 is 4. 12 plus 4 is 16. So we've gotten the molecular mass of sulfur oxide, 64, and the molecular mass of methane at 16. You can see that sulfur oxide is heavier than methane. So since methane is lighter, methane will diffuse faster than sulfur oxide. The heavier the gas, the lower its rate of diffusion. The lighter the gas, the faster its rate of diffusion. So sulfur oxide, methane will diffuse faster than what? Sulfur 4 oxide. So now we are looking for the ratio of the diffusion, that's rate of diffusion of them. So from Graham's law of diffusion, rate of diffusion of sulfur oxide is the formula you use. Rate of diffusion of sulfur oxide divided by rate of diffusion of methane equals square root of, you interchange it, molecular mass of methane all over square root of molecular mass of sulfur oxide. That's how you do there. So that's rate of diffusion of sulfur oxide divided by that of methane equals square root of molecular mass of methane, CH4, we got it as 16. Remember? Let's go back. Methane is 16, sulfur oxide is 64. So that's 16 over 64. Square root of 16 is 4. Square root of 64 is what? 8. So 4 here, 1 into 8 is 2. That's 1 over 2. So the rate of diffusion of sulfur oxide to that of methane is what? 1 is to 2. 1 is to 2. So what's our answer? Okay, 1 is to 2. So the best choice here is C. 1 is to 2. I believe you understand this calculation. It's very simple. Question number 2. If you look at this equation here, it is a nuclear reaction. I think this should be radon, and this one I'm not too sure. Anyway, these radioactive elements undergo disintegration to give what? An alpha particle. You know what's radioactivity? Radioactivity is a process whereby radioactive elements undergo what? Disintegration. It's a kind of spontaneous reaction leading to the evolution of a large amount of heat and what? Radiation. Now, the radiation that may come out or that may be produced during radioactivity can either be an alpha particle, a beta particle, or a gamma ray. Alpha particle, beta particle, or gamma ray. Now, in this case, when this element is a radioactive element, only radioactive element undergo radiation. When it undergo radiation, or let's say disintegration, as a nuclear reaction, it gave rise to another element with alpha particle as the radiation. Now, they're now asking what is the value of X. Now, this smaller element it forms, what is the value of its atomic mass? What's the value of its atomic mass? Now, I said that when the nucleus of an atom, now this radioactivity takes place in the nucleus of an atom, not unlike a chemical reaction whereby reaction takes place in the electron. Radioactive reaction or nuclear reaction takes place in the nucleus. Now, when the nucleus of an atom loses an alpha particle, the atomic number is reduced by 2 units, while the mass number is reduced by 4 units. Now, if you see here, since this radon here has disintegrated or undergo radiation to a smaller element, the atomic mass will be reduced by 4 and the atomic number will be reduced by 2. You must take note that each alpha particle is a helium nucleus. You can see here. Here is what? Alpha. This alpha is a helium nucleus. So helium is atomic mass 4, atomic number 2. So when 26 loses 4 units of atomic mass, becomes 226 rather loses 4 units of atomic mass, becomes 226 minus 4. Of course, this 88 will lose 2, become 86. So helium 4, 2. This equation must be the same. So therefore, X becomes what? 226 minus 4. 226 minus 4, and that's 22. So this equation, the reactants, the number of all these values in the reactants, if you add it, must be in the product, rather, must be the same with that of the reactant. Do you understand what I'm trying to say? Since here is 226, what you have here is 222 plus 4 must give you 226, and what you have is 88 here. 86 plus 2 must still give you 88. So the equation must be what? Balanced. So the answer is 226, losing 4 units, because 226 minus 4, that's 222. And your best choice is B, 222. Question number 3. The decolorization of purple color of the tetraoxomanganate 7 ion is a test for, is it alkenes, alkanols, alkanals, alkane. So now, out of all these compounds here, the one that is a reducing agent is alkenes. Alkenes is a reducing agent to bring about reduction, while itself will become oxidized. Do you understand? So I said that alkenes, e.g. ethene, C2H4, propene, C3H6, and are good reducing agents. Alkenes are good reducing agents. They will reduce the purple color of tetraoxide manganese 7 ions, which is MnO4, to colorless manganese 2 ions, which is what Mn2 plus in acidic solution. So alkenes reduce MnO4 from purple color to colorless in acidic solution, showing you that it's a reducing agent. If you calculate the oxidation of manganese here, it's plus 7, but here it is plus 2. That simply means alkenes has reduced it from plus 7 to plus 2. It's only reducing agent that does that. So the good answer or the correct answer here is alkenes. Question number 4. The gas obtained as a product of anaerobic action on organic matter buried in the earth is it ethene, is it methane, is it carbon dioxide, is it nitrogen? Let us see. Now, there's what we call biogas production. Now, look what I said here. Nowadays, biogas is produced in places like farms, where farm waste and manure are channeled to waste pits. If you go to some advanced farms, the droppings of the animals and their urine are channeled to a pit dug on the ground. We call it waste pit. All these weeds that have been removed, sometimes they place it there. Dead animals, they place it there. Everything organic. Remember, when you hear what organic simply means coming from a living thing. So materials, waste remain of food, waste food or waste feed of livestock. They place it in that waste pit. Urine of the animal, feces of the animal, they channel it to the waste pit so that everything will decay there. So now here, the waste pit is covered airtight and treated with bacteria. In that waste pit, they'll place a bacteria there. The name of that bacteria is Fusarium. They have a material where the bacteria is being cultured. They'll now place it in that waste pit and cover it tight. That bacteria will now convert that organic matter or that decaying matter, decaying feces, urine, or dead organism, and to convert it to methane and carbon dioxide. That is what that bacteria will do. It will convert it to methane and carbon dioxide. So all this happens in the absence of air, which is anaerobic, because that place is covered airtight. So oxygen cannot penetrate inside. So this will now convert all those stuff into what? The methane and carbon dioxide. Do you understand? That's the composition. Now this is known as biogas production. The methane gas is tapped and used for cooking, heating, and powering farm generators. This methane gas will now be tapped. In the farm there, they use it to generate light. In the farm there, they use it to warm, maybe if the weather is cool, to warm the environment. They use it for cooking. The farm workers can use that methane gas to generate fire, use it to boil water, to take their bed, to cook, to do many things. So now, this material, like the fecal material, if you don't want to use it as a manure, you can also use it and generate gas, use it to power generators. The methane gas can be used to power generators. We have generators that run on gas. So use it to power generators, use it to light up the farms, use the gas for cooking, use the gas for heating, and doing many other things. So the answer there is methane gas. It's methane. Methane is the important gas that is being, though carbon dioxide is also produced, but the important one there is, or the main purpose of that action is to generate what? Methane gas. Question number 5. The basicity of CH3COOH is. The basicity of CH3COOH is. Now they are asking you what is its basicity. First of all, what is basicity? Now this CH3COOH is an acid. So I said that it is an acid. We call it an organic acid. So the basicity of an acid is the number of replaceable hydrogen ion in one molecule of the acid. Do you understand? The basicity of an acid, the number of replaceable hydrogen ion in one molecule of the acid. Now, let's see the equation below. Now, this is CH3COOH plus NaOH to give you CH3COONA plus H2O. Do you understand? So CH3COOH plus NaOH to give you CH3COONA plus H2O. Now, if you look at this reaction, you will see that this sodium here replaced this hydrogen here to give you CH3COONA. The hydrogen here that was replaced combined with this OH to give what? H2O. Now, I said that we see from the equation above that CH3COOH has 4 atoms of hydrogen, but only 1 atom of the hydrogen has been replaced by sodium atom. So therefore, CH3COH is monobasic. So the basicity is 1. So because only 1 hydrogen has been replaced, the basicity is 1. If like in H2SO4, 2 hydrogen atoms are usually replaced, so the basicity is 2. In H3PO4, 3 atoms of hydrogen are usually replaced, so the basicity is 3. But in this case, only this hydrogen is replaced, irrespective it has 3 plus 1, 4 atoms of hydrogen. Only 1 was replaced. So because only 1 was replaced by sodium, the basicity is what? 1. So the correct answer here is 1. So I hope you like this video. Now, if you look here, you will see a link. We urge you to use this link to join us on our WhatsApp group. If you join us on our WhatsApp group, you're getting updates, infos on educational videos like this that will be very, very helpful to you in passing your Jamb, WAEC, and any entrance exam, depending on the subject you are taking, maybe chemistry, physics, or so on. So we are going to round up this section today. I still remain Mr. Chima, your prep class tutor on chemistry, and I'll see you next time. Bye and stay safe.